Hi Journeyman, this is Abuela again. This is the third video, okay? And this is week 20, hands-on science, okay? Now, remember Newton's third law of motion? Newton's third law of motion. For every action, there's an equal and opposite reaction, okay? If a force pushes down on a bridge, and today we're going to be talking about bridges. So if a force pushes down on a bridge, whether it be a car or people on it, and your bridge needs to push back, it needs to push up to hold the weight, correct? So you know that Newton's third law of motion is happening. All right, it's in effect. What happens to a bridge that is too long with no support? What do you think? That's right. It will collapse. The longer the bridge is, the weaker it becomes. What are some shapes that can help a bridge get stronger? Think about that. What are some shapes that can help a bridge become stronger? Okay. What are bridges for? That's the next question. What are bridges for? Okay. They help people, cars, trucks, cross over safely to the other side. When weight pushes down on a bridge, it's called compression. Under the weight, the bridge feels the stretch, called tension. It needs to be able not to snap. Okay. Now take a look here. I did a little picture of a bridge, okay? And there are people on the bridge. So, with their weight on that bridge, it's called compression, okay? But the under the weight, down here, under the weight, okay, the bridge feels that stretch called compression. If it didn't have support, in time, it will collapse. So, there are different types of bridges. How we can build bridges to be strong, to hold the tension. Okay, take a look here. The first one is a beam bridge. A beam bridge has a flat plank stretching over the two sides, and the beams are built underneath to help with tension. Well, that's what I did here. You have these beams, you see, on either side to help with this very short bridge. Okay, so it doesn't collapse. Now, a truce bridge has a frame of triangles. Take a look here. See the triangles? Okay, on the sides of the bridges to help spread out the pressure. So this is the beam bridge, that's the truce bridge. A suspension bridge looks like a beam bridge, but it has cables that come from up here all the way down. Like when you go into the city, some of the bridges that you see, the Brooklyn Bridge, you'll see the cables, okay? And it looks like this. See that? The suspension bridge. And it usually looks like an M, goes up, down, and it has kind of like the shape of an M. And then we have the arch bridge. The arch bridge, the Roman aqueducts, I guess kind of created it, and it kind of looks like this. Water usually comes, you know, it's usually built over water. And it was used a lot for aqueducts. Aqueducts means that the water passes through the bottom. Okay, and then up here you can walk or take your horses or take your car right over the top. And as a matter of fact, this architecture, a lot of it is standing today, which is awesome. So, over here we have the beam bridge. We have the truce bridge. We have the arch bridge, and we have the suspension bridge. Take a look here. So these cables have tension, and the compression is down here. towards the bottom of the bridges. Okay? That holds. It all helps to hold weight. So now, your science project, you have to build a bridge, okay, out of your straws. All right, so straw bridge. So you need about 50 straws. You might not use them all, but they give you 50 straws, rubber bands. You could use Play-Doh or tape, scissors, and try to find a way. I'm going to use books, okay, on either side. Make your bridge and see how much weight your bridge holds. And then you could take a picture of that and send me that, okay? So I hope you do well with it all. Have fun with your science project, building a bridge out of straw.